Hello, I'm Mr. Cleary, and I'm a 7th grade science teacher at PA Virtual. And today I wanted to show you some experiments involving color and chemistry. The first activity that I'm going to demonstrate involves acids and bases. In chemistry, an acid is any kind of molecule or substance that can donate a hydrogen ion. And a base is anything that can accept that hydrogen ion, or that can produce hydroxide, OH. If you combine OH and H, you get H2O. We often see acids and bases react strongly together, such as the case with vinegar, which is acetic acid, and baking soda, which is sodium bicarbonate. What I have done is I have created something that is called an indicator. An indicator is used in chemistry labs to show how acidic or how basic a substance is on a scale called the pH scale. The pH scale is a scale that we use to show how acidic or basic a substance is, with 1 being the most basic on the scale, 7 being neutral, like pure water, and 14 being very basic. Substances that are acidic are going to be substances that generally taste very sour, like citrus or vinegar, and stomach acid is also a very strong acid that your body makes called hydrochloric acid, which is necessary to break down the foods that you eat. Bases, on the other hand, tend to be very slippery and very bitter. We use a base called sodium hydroxide to make soap. What I'm going to do for my demonstration is I'm going to take my acid and base indicator and I'm going to show you several different substances. And we have here a scale for the acid-base indicator, with 1 being the most acidic. Is going to come up as a nice, very red, very pink color. Purple and bluish will be a more neutral pH. And as we move into the green and yellow, that will become much more basic in composition. So I will hold this up again to compare some of our substances. Let's start with rubbing alcohol. I don't have a pipette, so I'm just going to use a coffee stirrer and hold the end. I'm going to drop some of this substance. And this substance here, this is just red cabbage that was boiled, and then I've taken the juice and strained it out. So as I put the indicator into the alcohol, we're not seeing much of a change of any sort. This is because alcohol is pretty neutral. It's going to be the same pH as the water itself. So we'll just put that aside. Next, let's try vinegar. Vinegar has certainly a strong odor to it. I'm going to place some of this substance in here, my indicator, and already you can see, and you notice I'm not putting my pipette into the solution. We don't want to cross-contaminate. But already you can see the comparison, how the vinegar has this bright pink color to it, because the indicator is going to change color to show that vinegar is very acidic. This next substance I have here is NH3, otherwise known as ammonia. Ammonia might be used as some kind of chemical cleaner in your bathroom or in your kitchen. I'm going to add some of this to our solution of ammonia. And you can see that immediate bright green coloration to it. I'm going to add a bit more so you can see just how bright that is. What's interesting with ammonia and the chemistry behind this, I said the formula is NH3, but acids generally have hydrogens, which is what the H on this formula stands for. But what ammonia does is that it's going to take hydrogen from the water around it, so that H2O turns into OH. And the OH is very basic. The NH3 turns into NH4. So it's going to become very basic. And you can see just how basic that is on our scale here. It's almost a probably around a 12 or 11 on that scale there. Next, I have some lemon juice. This one might be a little hard to tell because the lemon juice is already very yellow, but I think you'll be able to see the color if I add enough of it in here. You can see that lemon juice now looks like pink lemonade because citric acid is the acid that's going to be found in fruits such as lemons, limes, and oranges. And it's actually what makes lemons taste so bitter, what makes them one of my favorite fruits. Up next, we have soda. This is just some 7-Up that I got from the grocery store. Soda has a lot of carbonation in it. And that carbonation that is put in the sodas is going to make that soda a little bit acidic. Not as acidic as the vinegar or the lemon juice. But you can tell compared to the alcohol, this is a little bit more acidic, but not quite as acidic as our other compounds. And this is one of the reasons why people advise not to drink a lot of soda. Not only does soda have a lot of sugar, but the acidity in drinking a lot of soda can also be bad for your teeth because acid can wear away at your teeth as well. And finally, I have a mixture of water and soap. I've made sure to gently mix this up. So let's add some of our compounds here. Slightly more basic than just the alcohol. Soap tends to be very basic. This hand soap must not be as basic as some of the other compounds. So this is an experiment that you can certainly try at home. All it needs is some red cabbages that you can get from a grocery store. You can boil it and extract this juice. Just don't drink it because it tastes very bitter. But then you can use it to try testing various substances at home. Try mixing it with water and baking soda and see how basic it is. And you can find a scale for the pH indicator online, like what I have here, so you can get an estimate of the pH or how acidic or basic each of these substances are. Thank you for watching, and I hope to see you again.